So now that I've done my scratch work, I can go ahead and try to complete this proof. So I'm going to use a direct proof technique to prove this implication. So using a direct proof, we assume our hypothesis is true, and I want to show that my conclusion is true. And I'm going to use the ideas that I had previously with my scratch work. So what I'm going to do is start with my left-hand side. And write that this thing is equal to 2 times 2 to the t. And then, since I have assumed that 2 to the t is greater than t squared, I can write that this is greater than 2 times t squared, and that's true by assumption. And now I want to somehow be able to get all the way down to some expression that looks like t plus 1 squared. So 2t squared. Well, that's the same thing as t squared plus t squared, right? So this is t squared plus t squared. And then let's go a little bit further. T squared is the same thing as t times t. Okay, well, how does that help us? Because remember, this expression right here, this thing is the same thing as t squared plus 2t plus 1. So what I'm trying to do is add on additional terms because I already got that t squared, I just need to fill in the rest. So, first off, is there anything special about this t? Well, this t is some element of the set that I'm talking about. Notice the set that I'm talking about, they're always greater than or equal to 5. They're always numbers that are bigger than 5. And so I can say that this is greater than or equal to t squared plus 5t. Since all our t's that we're talking about in this particular set are greater than or equal to 5. And now, we're getting closer. Let's go ahead and split this up, because I have two terms. I have a t squared plus a something times t. All I'm missing is this constant over here. So let's go ahead and force this to be a 2t. And that'll leave us left over with 3 t's. So I'm getting so close. I have a t squared plus 2t. All I need is to somehow argue that I can somehow, using an inequality, replace this with a 1. Well, t, remember, is greater than or equal to 5. And so 3 times something greater than 5, that's definitely going to be greater than 1. So this expression is going to be greater than, if I replace that 3t with a 1. Because the smallest 3t could be would be 3 times the first number. That would be 15. And 15 is definitely bigger than 1. And check that out. I have now been able to get to this right-hand side. So one more simplification. I get my t plus 1 squared. So I have successfully been able to go from this left-hand side, that 2 to the t plus 1, and show that it is greater than t plus 1 squared, and that is exactly what I wanted to show. I wanted to show that this thing was true. And so because of that, that ends our direct proof. So I know that this implication is true. And by my definition, that's all I needed to be able to do to be able to then conclude that our original theorem is indeed true.